Hi students, welcome back. Today we are going to look at another problem on LeetCode called the evaluating reverse polish notation. So reverse polish notation is a way to represent a expression or a equation. And here in this problem we have to solve that equation which is represented in a reverse polish notation. So let's look at the problem statement first. The problem statement says you are given an array of strings or tokens that represent an arithmetic expression in a reverse polish notation. We have to evaluate the expression and return the answer or the integer that represents the value of that expression. So the given conditions are we are only the operators allowed are only plus, minus, multiplication and division, and each operand may be an integer or one of these, one of plus, minus, or this one. The division between two integers always truncates towards 0, which means an integer division produces another integer. Okay, there will not be any division by 0. This is guaranteed. We don't have to check for that case. And input always represents a valid arithmetic expression. So we don't have to check whether the expression is valid or not. Okay, and the answer and all the intermediate calculations can be represented in a 32-bit integer. Okay, so we don't have to look for integer overflow as well. Okay, so let's first understand what is reverse polish notation. Okay, we all know that we represent any equation like this. Okay, let's say there is a plus b into c. Okay, so we put braces and symbols between the numbers. So there are two numbers and the operation that happens is between them. Okay, this is called infix notation. Okay, so reverse polish notation is another way of representing it where you write the numbers first followed by its symbol. For example, a plus b becomes ab plus. Okay, and there is into c. Correct? So this becomes AB plus C into because the operation pushes towards the end. Okay, this is called the postfix or reverse polish notation. Okay, now there is something called prefix notation as well, where the symbol comes to the start. So this becomes plus AB, and this is one number, right? Into C. That into also comes to the start into C. Okay, this is called prefix notation or polish notation. Okay, now what we are interested in is this one, reverse polish notation. So we are given a number which is represented in a reverse polish or we are given an expression represented in a reverse polish notation and we have to find its value. Okay, let's take an example and see how we can do that. Okay, let's look at the first example. So here are the tokens that are given to us. Okay, so we are given 2, 1 plus 3 and multiplication. Okay, so let's see what we can do with it. So what we are saying is this essentially becomes, this is postfix. So this becomes 2 plus 1. Okay, 2 plus 1. This is another number and this into comes to the multiplication comes before the number into 3. So 2 plus 1, 3 into 3, which is 9, which is the answer. So how can we solve this? If you clearly see, this is, we can basically use stack in this case. Okay, let's see what happens if we use a stack. Initially, so in the stack, what we will do is as long as we see a number, we will push the numbers to the stack. Okay, the moment we see an operation, we'll take the top two and apply that operand. Okay, so here initially we have 2. We will push it to the stack. 1, it is a number. We will push it to the stack. Now we are getting a operand which is plus. Now what we have to do is we have to pop these two numbers and push the sum to the stack. So the stack becomes this becomes empty. This becomes 2 plus 1, which would be 3 here. Okay. Okay. So as soon as we saw a operand, we applied that on the top two numbers in the stack. Next we get 3. Another 3. We push that also to the stack. After that we get multiplication. So we pop out the top 2 and do the operation and push it to the queue. So this becomes 3 into 3, 9 now. Now we are at the end of the stack. So stack will have only one value, which would be our answer. So 9 is the answer. Okay. So the using a stack here makes it very simple. Okay. Since we have numbers and then operand, it clearly fits in a stack pattern. Let's take another example. Let's say we are given these values. Okay. Now, if we follow the same stack way, okay, okay, let's say initially our stack is as usual empty. Now we have 4 at the start. So we'll push 4 to the stack. Then we have 13. We will push 13 to the stack. Then we have 5. We will push 13 to the 5 to the stack. Then we get division. So we take out the top two numbers and apply the operation, which would be 13 by 5. Okay, 13 by 5 would be, we are only doing integer division, so it would be 2. So at this position, the number will change to 2. Now the next value is plus. So we can take out the top 2 and apply the operation, which would be 4 plus 2, which is 6. So our stack now becomes 6. Now we are at end of the expression. So this is our answer. Okay, 6 is the answer. Okay, so here if you see, when you are doing minus and division, you have to be careful. This one is the first part of the equation. This one is the second part of the equation. Okay, so when you are doing a division, you have to, top one is the second part of the equation. The one below it is the first part of the equation. Okay, that is the care we have to take. In case of plus and multiplication, it's the same. Okay, so let's apply this in code and see how we can solve this problem. Okay, so this is what we have. Now, initially, what we need is a stack. So in Java, like we have seen, we will earlier in the previous problems as well, we will use DQ for a stack. So let's initialize a DQ. Okay, and we have to traverse the all the tokens given. So what we will do is, for each token, we will figure out what to do. Okay, what do we do? If it is number, if the given token is a number, we have to push it to the stack. Stack dot push. What will we push? We will parse it to integer and push, because we will have to apply the operation anyway. And our stack is a integer stack. So we, if it is a number, we are parsing it to a number and pushing it to the stack. Else, okay, we will get the numbers. We'll pop two numbers from the stack. Okay, so the top one would be N2. Okay, so here we don't have to do any checks, because we are guaranteed that it is a valid expression. Okay, otherwise we'll have to do some validations, and we have to do some computation on this using the correct current token. Let's say we have a function called compute, which can do that for us. We pass this to that function and we push the element to the stack. Okay, finally, once we are done, stack will be left with only one element. Again, we don't have to do any checks, because it is a valid expression. We just have to return that. Now we have two functions here to implement, is number and compute. Also, this parseInt might throw number format expression, but as per our problem statement, that should never happen. So let's just say throws number format exception. Okay. Now we have to implement two functions, which is number and compute. So is number, it basically takes a string and returns a boolean whether it is a number or one of the operands. Okay. So here we are guaranteed that the token has only plus, minus, multiplication and division. If it is not any of those, that means it is a number. So we can just do that check. Okay, equals token, or if, or it is minus or multiplication or division. If it is not equal to any of those, that means it is a number. Okay. Now the other function we have to implement is, we have to check if the given value, given two numbers and a string operand, we have to check if we have to apply that operation and return the result. So initially let's assume result is 0. Okay. So we have four cases here. Let's use a switch case for them. So switch is on the operand. Okay. So the first case is when it is plus. Okay. Okay. When it is plus, what will we do? Our result becomes result equal to x plus y. Similarly, we will have three other cases. Okay. And we should always have a default. In default, we don't have to do anything. I'm just printing that this case never happens, because again, we are guaranteed that it's a valid expression. Otherwise, we'll have to handle this case. Finally, we have to return the result. So let's adjust this. So if it is minus, we have to do x minus y. If it is multiplication, we have to do x into y. And if it is division, we have to do x by y. Okay. So this is our algorithm. Let's run this and see. There is some, okay, we missed S here. Still token. Okay, let's check the other values as well. Yeah. Dot equals token and oh, okay. Okay, let's submit this and see. Okay, so it ran fine. So what is the time and space complexity here? We are traversing the input once. So the time complexity is obviously order of n. And we are using extra stack for memory. So the space complexity is also order of n. So our algorithm here is pretty simple. Okay, let's go over the code again and see. Okay, so we are creating a stack here like we have seen in the dry run earlier. Okay, and once the stack is created, for each of the token, if it is a number, how do we define if it's a number? If it's not any of the operand, it is a number. If it is a number, we simply push it to the stack. If it is not a number, we take out the top two numbers from the stack and apply the operation, which is the token on it. So how do you apply the operation? If it is x, if it is plus, you do x plus y and so on. Okay. So we define two functions, compute and is number, which does exactly that. So this way, instead of writing everything in the single function, if you modularize it into separate functions, your code will look much cleaner and it will be easy to read. Okay. Hope you followed through the problem. As a homework, what you can do is you can solve the polish notation. Here we solved it for reverse polish notation. Like we discussed it during the example, there is something called polish notation as well. You can make a simple modification to this and solve it for polish notation. You can attempt that. Hope you enjoyed the video. Please like, share, and subscribe. Thank you.